Hello friends, Vidura here. I will show you an experiment which is inspired by the Russian investigator Sergei Dana. I have replicated this circuit to make some testing. I will show you this is the schematic of the circuit. You can see this is the supply voltage. The first switch here is providing a narrow pulse to drive this parallel LC oscillating resonant circuit. I have placed sensing resistors for the current in the branch of the inductor, in the branch of the capacitor, and one for the input coil, for the input pulse, sorry. And the last probe here is for the voltage. This is the common ground for all the scope probes. And this switch here are two MOSFETs connecting back to back to provide a bidirectional switch, which is used to short the circuit in a certain period of the cycle. Okay, here I'm using here the floating switching modules from the modular switching tool to provide the timing for the circuit. And here on the scope I will show you. This here is channel 4 in the middle. It's set to the zero graticulate line. It's in 0.1 volt and all the entrances are in DC mode. The green one is channel 3, which corresponds to the inductor. Then channel 2 is the voltage probe, which is in 1 to 10, is 10 volt by division, and I have it inverted due to the position of the probe, because the probe is on the negative side. Okay, here first we will see this is the channel 1 with the impulse driving pulse. This is a very narrow pulse which just is enough to keep on the resonant oscillation. Here in this channel we have the branch of the capacitor, which shows the current on the capacitor side, which when the switch is shorting the circuit, it goes to 0 and then recovers. Here we go. I will take away the input current for more clarity. So this is the voltage. You can see here the driving pulse, which adds some potential on the maximum voltage point. And then here in this area we have the circuit shorted with the other two MOSFETs, with the second switch. Okay, now we will add the channel 3, which is the inductor. And here you can clearly see, we will turn off for a moment to check the zero line. We'll put this exactly here on the 0 line. You can see the current is in antiphase to the capacitor as expected, and in the moment of shorting it sustains in maximum in the area of the shorted coil, which is an indication that the current is recycled through the shorting, through the switch which is shorting here, into the same coil, and is recycling inside this coil until the shorting is turned off, and then the cycle recovers and goes on its resonant oscillation. we can vary the time of the shorting. We have to readjust a little bit the frequency for the resonant point. Okay, here we go. Now you can see we have a much shorter. So we can, with the same parameters of the resonant tank circuit, we can vary the frequency, the actual frequency, by inserting a kind of stalling, of dead time inside the cycle. Okay, thanks for watching.